Hi everyone! So, has anyone ever given a lot of thought to how they build theme parks? When I was in middle school, we were tasked with building our own theme park on a computer simulator. It was really cool and our theme park turned out really awesome. A few years later, we learned the math behind our theme parks. What if I told you that theme park designs are built almost entirely around trigonometry? What? So, today we're going to do a brief introduction to trigonometry through the sine and cosine functions. I'm calling it a brief introduction because, put very simply, trigonometry is the study of triangles. Specifically, this kind of trigonometry focuses on right triangles, which are triangles with one 90-degree angle. You may have heard the phrase right triangle trigonometry or even right triangle trig before, and that's what we're moving into. Overall, trigonometry is the beautiful study of triangles and angles and shapes, and you'll have circular trigonometry, but we're going to focus on right triangle trigonometry. It's a little simpler. So let's take a look at triangles. So in a typical right triangle, by definition, you have three sides and one right angle. So given this triangle ABC with a right angle at angle B, we have our three sides and we have our angles. In this case, I have an angle theta located at the bottom corner, and you have an opposite side to that, which is the side opposite from the angle theta, and an adjacent side, which is the side attached to theta that essentially makes the angle. In this case, theta is down by angle A, but you could have triangles that have your unknown angle at either side, because theta can be either the angles that's not the right angle. So in other words, in a right triangle, your unknown angles need to be acute angles. Sometimes you'll need to figure out specific facts about the sides of your triangle. If I give you a triangle like the one below, where would you start to find A? So that's where the sine and cosine functions come in handy. The sine and cosine functions are the two most prominent functions in trigonometry. In fact, all other trig functions can be expressed in terms of sine and cosine. So let's learn more about these two. So the ratio of the opposite side of a triangle to its hypotenuse is called the sine, which is pronounced like the word sine. So in a right triangle, the sine definition basically says that all the following are related: the measurement of one of the non-right angles, i.e. theta, the length of the side opposite to that angle theta, and the length of the triangle's hypotenuse. This does not mean they are equal, it means they're related, and you can find the three based on the other two. So in our equation, sine theta equals opposite over hypotenuse. As long as I have two of those three pieces, I can find the third piece. Similarly, the ratio of the adjacent side of a triangle to its hypotenuse is called the cosine, which is pronounced like the word cosine. Go home and tell your parents all about this. They're going to love it. Similar to the sine function, the cosine function says that the following are also related: the measurement of one of the non-right angles, so again, theta, the length of the side adjacent to theta, and once again, the length of the triangle's hypotenuse. Like I said with sine, this does not mean they are equal, that means they can all three be found based on the other two. So in our equation, cosine of theta equals adjacent over hypotenuse. As long as I have two of those three pieces, I can find the third piece. To make things a little bit easier, we abbreviate the word sine as S-I-N, but it's still pronounced like sine, and we abbreviate the word cosine like C-O-S, but it's still also pronounced like cosine. This may seem redundant or even a little silly, but it makes writing a lot easier, and since the alphabet doesn't have the same letters all over the world, these three-letter abbreviations make translations a lot easier. So you could speak with somebody who has a different language background than you, and they would understand your sine and cosine functions. The sine and cosine of an angle theta is often found by saying the phrase so, ka, toa, which we'll learn more about when we learn tangent tomorrow. For today, just remember the two introductory functions, sine and cosine. If we look down at our graph below, we see that sine is represented by SOH, which stands for sine, opposite, and hypotenuse. So the sine of an angle equals the opposite side length or the hypotenuse side length. Next to that, the cosine of an angle is given the expression ka, which stands for cosine adjacent hypotenuse. And that tells us that the cosine of an angle equals the adjacent side of the angle over the hypotenuse of that triangle. Tangent has to do with the opposite side and the adjacent side, but we'll learn all about that tomorrow. So I want to finish you today with a little pun that I completely adore, because remember, when mathematicians start talking about math puns, it's usually the first sign of madness. Get it?